Welcome to Train Signal. I'm Mel Haynes, and in this video, it's the first of a series of videos looking at high availability. In this video, however, I want to introduce you to high availability kind of at a high level, looking at some of the different options you have available and comparing them. And then in subsequent videos, we'll delve into the individual high availability options. But in this video, we'll get into high availability options. What are your choices, first of all? And then I'll give you 4 what is type topics. What is failover clustering? What is database mirroring? What is log shipping? And what is replication? So we'll talk about that. And then I want to jump into starting to take different high availability options and combining them to get the benefits of each option. So we'll look at replication and database mirroring combined. Now, I'm not going to try and get into every possible permutation of all 4 of those different types. That would be beyond the scope of this course. And it's really replication and database mirroring is probably the pairing that is most important to be aware of. And then last but not least, I want to leave you with a chart that lets you just kind of in one place get a feel for why would you pick one high availability option over another. So we'll end with a comparison of what are the different features and how you would go about selecting a high availability option. When we talk about high availability, there are really 3 main choices, I'll say. Now, there's some debate on what features of SQL Server are really high availability features, but there's at least 3 core ones that I'm going to introduce, and then I'm going to bring in a 4th that there's some debate over, but it's good to cover it here as well. But the 3 main ones include, first of all, failover clustering. That's definitely a high availability feature that's used so that you're no longer connecting to a single server, but you're connecting to a virtual server that under the hood is actually any one of several servers or several nodes that make up a cluster. Database mirroring, that's also a high availability feature in that in the event of a outage, you have a mirrored copy of your database, and we have different configurations that are available under database mirroring that can give you different pros and cons as far as how you implement that. And then the third one is log shipping, where with log shipping you're taking your transaction logs and you're shipping them like the name says, right? You're sending your transaction logs to a second and maybe even additional servers, and then you're applying those log files to another instance of SQL Server, actually another database on another instance. And then in the event of an outage, you have your information available on another server. Now, those are your 3 core ones. A 4th one that is often also listed as a high availability feature or just a feature of SQL Server is replication. Now, replication is one of my favorite features. I think it's just really cool to be able to segment your data and send portions of it to different servers. And that's what replication is all about. So if you need a subset of your information at a particular location, a particular remote location apart from your main office location or your headquarters, right? Replication is definitely the way to go. Now, some might say replication is not a high availability feature, however, because you aren't really creating other copies of your data to support an outage. You're actually creating other copies of your data to support your day-to-day operations, and your primary data store is still really needed and has to be in place for your primary users to have access to the data. So for example, if you have replication set up in your corporate headquarters and then you have segmented data based on geographic location being sent out to different offices around the country or around the world, well, if the main headquarters goes down, the replicated copies at the remote locations may or may not be available to people at the headquarters, right? That's not really a built-in component of replication. You could probably find a way to have access to it, but that isn't really how replication is primarily designed to work. But here, let's dive in a little more detail on each one of these options. Starting with failover clustering. Failover clustering provides high availability for an entire instance of SQL Server. And you'll want to pay attention as we go through these as far as which ones are instance related or instance scoped and which ones are database scope. Clustering is instance scope, which means every single database on a particular instance or copy of SQL Server that's running, every single database will be part of your cluster. You do not have the option of clustering individual databases on an instance. It's all or nothing. Well, that's totally fine, because in most implementations, when you're investing the time and resources to have a cluster, you probably won't have multiple databases running on that instance. It'll typically be a dedicated instance for some very large scale operation. Let's take a hotel chain, for example, that runs all of its reservation system on an SQL Server installation. Well, that's going to probably be a dedicated instance of SQL Server. They're not going to typically have multiple other general use databases available on the same instance. The same thing is true with our Veronica's environment. We've gotten large enough now that we don't want to have multiple other administrative databases running on our primary management server. So it's going to be dedicated. Second, failover clustering is going to be made up of a combination of one or more servers called nodes, typically at least two, that are hidden, so to speak, from your clients behind a virtual server instance. So from your client's perspective, they're interacting with a virtual server. They don't really need to know that. They don't know that. But behind the scenes, SQL Server knows that that virtual server needs to be mapped to a specific server at any particular moment in time, mapped to a particular node in the cluster. Getting into the hardware, with clustering, you're going to have two or more shared disks. Now here's something key to keep in mind with clustering. When you're dealing with clustering, clustering does not provide fault tolerance for disk failure, because all of the nodes in the cluster actually share the same hard disk. That is not redundant. That is not repeated in multiple locations. It's really the OS and what's hovering on top of the hardware that is redundant. So in the event of a software glitch, a server lockup of one of your nodes, you can easily switch processing to another node. But in the event of a hardware failure, you'll need to have something else in place, such as a RAID type of an arrangement in place. When you're working with clustering, you're dealing with what's known as an application service, which is a virtual name, and it's independent of any one of the servers or nodes that are part of your cluster. And it's referred to as your failover cluster instance name. So it's sort of like you have a single server on your network, even though there are multiple ones, and that single server is actually a virtual server. So the applications don't have to know which node is currently hosting the failover cluster, which node is currently active. They don't know and they don't care. So your SQL Server failover cluster is going to appear on your network as a single computer. And as I said before, here's a big drawback to clustering. A failover cluster, however, does not protect you against a disk failure. That will have to be provided for separately. What's commonly utilized for that is some type of a RAID arrangement for protecting your hardware. Failover clustering is going to be one of your more expensive high availability options. It can provide incredible robustness, incredible failover capability, but it's going to be your more cost prohibitive option. You can use failover clustering to reduce system downtime and provide higher application availability because of the fact that you'll have multiple OSs ready to go, always alive in case something goes wrong. Your hardware will have to be protected separately. Where can you use it? Failover clustering is supported in SQL Server Enterprise, as well as SQL Server Developer and SQL Server Standard. And if you remember the differences between those, really only two of those can be used in production, right? Your Enterprise and your Standard. SQL Server Developer is only for development environments. It has all the capabilities typically of the Enterprise Edition, but you can't roll that out into production. It's only for development and testing. So pros and cons one more time on failover clustering. Automatic detection and failover. When it works, it is seamless. You do have a choice for manual failover with failover clustering. As far as your clients are concerned, all redirects are completely transparent. Failover clustering supports file stream data. We talked about file stream data in other places where you can have binary data of various types simply stored in the file system. and it's managed via an SQL Server table. So you'll have a column within SQL Server that is being used to represent your file stream data, which is physically stored on the hard drive, separate from the rest of the table. Failover clustering has complete support for file stream data. Now, some cons: operates at the server instance scope. Once again, that may or may not be a problem, because typically if you're implementing a failover cluster, you've got a pretty high-end, highly utilized application, and you're not going to be putting multiple databases on your server anyway. Requires a significant hardware investment. That's probably one of the biggies. This is for the big boys. This is not something you're going to implement in a mom and pop shop. This is going to be for a large-scale database operation. No reporting on standby. We'll get into some of the other types of high availability where you've got this other box just kind of sitting out there waiting until something goes wrong. Well, you don't really have that in clustering. All of the boxes are in essence really focused on servicing one database instance. It utilizes a single copy of the database. You're not dealing with multiple databases, and you are copying everything on the instance. Does not protect against disk failure. I've said that a few times, but that's a biggie to keep in mind. Clustering does not give you fault tolerance against disk failure. Moving on to our second option, database mirroring. Mirroring is typically a two-server type paradigm. It involves a principal database and a mirror database. And notice I'm not saying instance this time. I'm actually saying database. That's because mirroring operates at the database level. So here's something you can use in a medium to small size operation where you may have multiple databases running on an instance of SQL Server. Now you can, and actually you have to, set up individual mirror sessions between a principal and a mirror database. So if you've got 3 different databases on your production server, you'd set up 3 separate mirror sessions. The mirror database is inaccessible to clients, so you will not be utilizing that directly unless it's turned into your principal. However, you can create a read-only snapshot of the mirrored database that can be made available. So it gives you the ability to get more utilization out of that mirrored server. And there's actually other ways to get some utilization out of it. We'll talk about that later in the video specifically on mirroring. Now you have 2 main modes when you're talking about mirroring. There's the synchronous and the asynchronous. And the Microsoft speak on that, or their actual terms for that is the high safety mode, that's synchronous, versus the high performance mode, that's your asynchronous. What's the difference? Well, if you know what synchronous versus asynchronous means, then you're dead on. But here, synchronous is all about I'm going to wait until the commit is completed before I move on. So if you're dealing with a synchronous operation, your client makes a change to the database on the principal. That change is mirrored to the mirror database, and not until both changes are committed does the client get a confirmation that the transaction is complete. So you could have a possible increase in lag time if you're waiting for your change to commit on 2 servers versus 1. The downside, performance could suffer. The upside, you know all of your changes are replicated. And I probably shouldn't use that term since that's a specific term in SQL Server, but you know all of your changes are saved on both servers. In asynchronous mode, the mirrored server is trying to keep up as fast as it possibly can, but if it lags behind, no worries. Your principal is free to continue on, and they will resync or catch up when the workload allows them to. The downside there, if your principal goes down, any changes that haven't propagated over to your mirror could be lost. There is a slight twist on the high safety mode, known as high safety mode with automatic failover. It involves a 3rd server, which is known as a witness server instance. This allows mirroring to have an automatic failover capability. So now, not only do we have high safety mode where all the changes on the principal are automatically written to the mirror and nothing else happens until that's completed, we can also automatically switch over to our mirror server, making it the principal in the event that the principal goes down. That's available by having a third server instance that serves as a witness. Where can you run it? Well, database mirroring partners and witnesses are supported on SQL Server Standard and SQL Server Enterprise Edition. One little requirement, your partners have to use the same edition. So you can't have a principal on the Enterprise where the mirror is on the Standard. Also, you don't want to have the principal on SQL Server 2008 and a mirror on Server 2005. They should all be exactly the same. The high performance mode, which is also our synchronous mode, is only supported, however, on SQL Server Enterprise Edition. So there's a further restriction. Now with your witnesses, however, that's an interesting term, but now with your witness server, you actually have an additional option, because that's not really going to be servicing clients. It's just kind of sitting there waiting to see if the principal goes offline. So you don't want to have to invest quite as much with that server, and you don't have to. Your witness can actually be SQL Server Workgroup as well as SQL Server Enterprise. So those are far cheaper options as far as licensing goes. Some pros and cons when we're talking about database mirroring. First of all, a big pro, automatic detection and failover. That's a biggie. When you want high availability, depending on your shop, especially if you don't have something that's manned 24/7, you want to be able to automatically fail over in the event that a server goes down and have that backup server that's kicking in be up to date with all changes. You have that capability with mirroring. You also have a manual failover. Let's say for administrative purposes you want to force failover from your principal to your mirror because you need to upgrade your principal. You can do that. Client redirect is completely transparent again, sort of like your clustering. Now in this case you're only moving from a principal to a mirror, but it's transparent to the client. It uses a single duplicate copy of the database. So you'll have copies of your database, one on the principal and one on the mirror. Uses standard servers, and what do I mean by that? You don't have that extreme hardware outlay that you would have with clustering. So your standard servers that you would use are going to be just fine for mirroring, just so long as they're the same. That's really the key thing to know with mirroring. They need to be the same. When you're implementing mirroring, you can actually utilize the mirrored server by creating snapshots and then utilize it for limited reporting. So you get a little bit more utilization out of that additional hardware. There's actually other things you can do with that mirrored server as well that are beyond the scope of this video, but I get into those in the mirroring video. Database mirroring can provide zero work loss in the event of a server failure. That's part of your high safety mode again, which says every change made on the principal, before we give a confirmation back to the client, we make the same change and wait for it to commit on the mirror. In that configuration, you have zero work loss. It operates at the database scope. Now that's really a pro or a con depending, right? Really in most environments, if you're dealing with mirroring, that's fine. You can do it at the database scope level, and there's no law that says if you have 3 or 4 databases on your instance, you can't have each one of those in their own mirroring session. You can do that, but they will need to be separate. It operates at the database scope. Now for some cons, and here's really the only biggie for mirroring in my opinion, no file stream. If you need to support file stream data, then you have just excluded the possibility of using mirroring. If you try to enable mirroring with file stream data on your database, you'll get an error during the setup. So it's not supported. Next, looking at log shipping. Well, log shipping is actually in some ways similar to mirroring in that you're sending information, transactions, over the wire to another server. It operates at the database level, also like mirroring, but there are some differences. You can use your secondary server for reporting with log shipping. You can do that also with mirroring, but you had to make a snapshot first. Not necessarily the case with log shipping. And here's probably one of the first significant differences. With mirroring, it's always a one-to-one relationship. One principal, one mirror. With log shipping, however, you can ship the logs to one or more additional servers. So you can have multiple warm standby servers when you're working with log shipping. Here's the other really big difference with log shipping versus mirroring, for failover to your secondary database, you have to first of all complete the log shipping process manually and then manually bring that other server online. So this is a completely manual process, and it's a rather involved manual process because you're shipping log files. If your primary server goes down, hopefully you can get to the last of the log files. You'll need to get to that. Then you'll have to apply that to your secondary database or databases before you can bring them online. Where is it supported? Supported in the Enterprise Edition, the Standard Edition, as well as the Workgroup Edition of SQL Server. Now, some pros and cons with log shipping. I've mentioned a lot of them already, but we'll run through them again. It supports multiple secondary databases, so that's different from mirroring, definitely. It supports file stream data again, so that's another big difference and an advantage over mirroring. Another advantage, which is also in some ways a disadvantage, there's a time delay between what happens on your primary database in a log shipping scenario and what's available on your secondary, and you can adjust that time delay. That can be an advantage if something happens on your principal database that you don't want to appear on your secondary database. You have a window of time where you can basically intercept that change. The cons, the exact same issue. There is an inherent lag time when you're dealing with log shipping between a change being applied to your primary server and it being implemented on your secondary server. And there is no automatic failover with log shipping, so that's the other biggie. All right? But the big Benny really for log shipping is you can have multiple secondary servers, so it can be a great way to have your data available to multiple locations using log shipping. Now, I'm going to jump into replication, and as I stated earlier, replication in and of itself doesn't really provide high availability. Another term that's not really a Microsoft term, this is a Mel term, I'm inventing it on the fly. I'm going to call it distributed availability, in that you can have your information available in more places, all right? Which in some ways does give you higher availability. But let's talk about it in more detail. First of all, when you're dealing with replication, you're going to have what's known as a publisher and a subscriber. And the publisher is the source of that information that is then made available on your secondary servers, known as subscribers. You can have multiple subscribers. So in that sense, it's similar to log shipping because you can have not just one, but you can have multiple servers that are receiving the updates from your principal database. Next, it enables real-time availability across multiple servers. There's no such thing as a warm standby when you're dealing with replication. All the servers are up and running and servicing clients. So that's a pretty cool feature. It supports filtering and partitioning of data sent to the subscribers. This is probably one of my favorite features of replication. I can say I only want customers for Virginia sent to the Virginia office, and I only want customers sent to California that have certain characteristics. So I can filter the information based on characteristics, and I can also partition. So I have both choices available. Subscribers, once again, are online and available for reporting or any other function without any special query recovery or anything else. Your subscribers are actually considered part of your active data implementation. It's supported in all editions of SQL Server, so you have that available across the board. Publishing, however, the source of the data, is not available with SQL Server Express or SQL Server Compact Edition 3.5 Service Pack 1. So those are two restrictions you'll need to know. Now, I don't get into pros and cons of replication on purpose because I don't want to put it next to the others as you can do this or that for high availability. When you're dealing with making sure your data is available in the event of a system crash, really you want to pair replication with something else. But once again, what does replication actually provide you? It gives you filtering in the database to provide a subset of the data at the secondary database location because it operates at the database scope. Second, it allows more than one redundant copy of your data. Now, you could set up replication to replicate an entire database and have it sent out to multiple locations, but you really don't have automatic failover. You have the entire database copied to other locations and have clients that are accessing the data at those locations. Third, it allows real-time availability of your data, and it's scalable across multiple databases supporting partitioned updates. So you have a lot of control over what gets sent and where, and it allows complete availability of your secondary databases for all functions, reporting, querying, anything you need to do without any other special query recovery or applying log files or anything. So I did want to mention a pros and cons of replication next to the other three, because the recommendation is a typical implementation might be replicate your data to remote offices and then mirror the replicated data at each location. That would give you your actual fault tolerance. But those are two separate tasks. So we've looked at the individual options you have available to you when it comes to high availability. But I talked about some shortcomings with each one of them, especially replication. For all it can do, it really doesn't give you what I would call true a high availability by itself. You can, however, combine replication with other high availability options. The most recommended would be replication with mirroring. By using those two in conjunction, you can actually mirror your publication database. Now, we didn't get into replication in detail in this video, so let me backtrack on that. With replication, the database that is the source for the information that gets copied out to other locations, that database is known as your publication database. So if you're dealing with a data warehouse, let's say at your corporate office, and then you have subsets of that data that you want to make available at various remote locations, the data at the main office, which is all of the data, would be your publication database. You can use mirroring to have a second copy of that data available and have it set up for automatic failover. And then replication failover, as I said, to a mirror is supported for your publication databases only, which also means the flip of that, you cannot use mirroring against any system database. And we talked about that in a different video. Your distribution database is basically a system database. So you cannot mirror your distribution database, nor can you mirror your subscription databases. So that means the information that's been copied out, that subset that's been copied out to remote locations, you do not have the option of setting up a mirror of that information. You could also use log shipping with replication. However, database mirroring is recommended over log shipping if you need to have additional fault tolerance for your replication. And then looking at selecting a high availability solution. Now I've started with two right now on the screen, failover clustering and then failover clustering with RAID. When you're dealing with clustering, you're dealing with a fairly expensive high availability option, but failover clustering with RAID is by far your most robust high availability option. Notice by adding RAID, you take away the one negative with clustering, and that is clustering does not provide disk failure protection. But by using a RAID architecture, you've added that in and come up with by far the most complete high availability solution. But it is also, once again, the most expensive. Next, we talked about database mirroring. What does it provide? It provides automatic failover, just like clustering. It does not provide file stream support. So there's one thing it doesn't have over clustering. It is database scope versus server scope, which isn't necessarily a bad thing, but it's just something to be aware of. You do have disk failure protection because you're mirroring that database to a second physical server. And then as far as work loss, if you're in the synchronous mode, the high protection mode, you have zero work loss. Next, log shipping. Log shipping does not provide automatic failover. It's a manual failover only. It does, however, support file stream. So if you need to have file stream data, Your choices are clustering, which is more expensive, or log shipping, which is going to be more resource intensive as far as human resources. It is database scoped, and it provides disk failure protection because you're shipping the logs to a separate physical server. As far as work loss, however, there will likely be work loss with log shipping because there is a time delay inherent in log shipping before that log is shipped to the second server. And then replication with mirroring. I didn't even include replication by itself because it really should be paired with something else. So automatic failover is kind of inherent in replication. There really isn't a failover. The multiple locations are always available. But by pairing it with mirroring, you can have automatic failover for your publisher, which is the source of your data, not your subscribers or your distribution database. No file stream support because that's inherently a part of mirroring. It will still be database scope. Disk failure is now in place because you basically inherited that from mirroring, and the zero work loss is in place because you've also inherited that from mirroring. One caveat on that. We've only talked about replication in one direction in this video. Replication can actually be two-way. You can have changes at the publisher, the source, the ultimate source of the information. You can also have changes occurring at the subscriber, the location that receives the data from the publisher. In that case, that information would not be protected via mirroring because you can't mirror the subscriber. But if you're dealing with changes at the publisher only being sent out to the subscribers, it's possible to have a zero work loss configuration if you pair replication with mirroring. So with that, we've come to the end of this video. Let's recap what we've talked about. First of all, I talked about the high availability options, and I actually drew a distinction between replication and the other three, with the other three being, once again, clustering, log shipping, and database mirroring. Next, I gave pros and cons for clustering, pros and cons for mirroring, as well as pros and cons for log shipping, and then we looked at replication, its benefits, and uses. After that, we jumped into pairing replication with other high availability options and focused specifically on the benefits of replication combined with database mirroring. And then last but not least, I did a high-level overview of what are the pros and cons of your various high availability options to help you in selecting the best high availability solution for your environment. So with that, we come to the end of this video. Thank you so much for watching, and I look forward to seeing you in the next video.